Hello everybody, today we're going to talk about kinematics and see what it is. This can be my first video in my, I hope to continue this AP Physics 1 series. So today we're going to talk about kinematics, like I said. Kinematics. Alright. So if you don't know what kinematics is already, you may be asking, what is it? So I'm going to give a straight up definition when I think about kinematics. So kinematics is describing motion using graphs, and equations. So this is kind of like my definition of it. That's what I think about kinematics. We're pretty much describing the motion mathematically, right? Alright, so let's do an example. Let's do a stationary ball. Okay. I don't have my table in front of me, so I can't describe or show you it, but I'll just write it on the board. So let's say we have a ball right here, and I can track or something. So I'm going to use this ball a lot. Let's call this ball Tinito. So Tinito. And it's not moving at all. There's no force to anything. So, and it's at currently, say it's a meter stick. It's at, say 20 centimeters. So it's at 20 centimeters. And then here's the origin, and then it continues on to whatever, since we call it positive x. And you notated that. Okay. So we want to describe Tinito here using a graph and then an equation. Okay, so let's use a graph. So we're just going to have a xy plane right there. Okay. So as Tinito is stationary on the 20 centimeters, no, we're not going to worry about that for now. Let's go over how to label the graph. So in physics, we'll label the graph and the x-axis t for time, and the y-axis x for distance. This is what we call time position graph, right? It's a little different than a normal graph, but you should get this easily. It's not bad. Okay. So let's now get on this. So let's say this is 0, it's putting the origin there, and for 0 seconds, Tinito is at 20 centimeters. So 20 centimeters. Let's label centimeters. Okay. At let's say 5 seconds, still at 20 centimeters. Now let's go on to a million seconds. It's still at 20 centimeters. Okay. So as this object's stationary, it's gonna have this line here that won't move at all. Won't increase, won't decrease. It will just stay like that. Okay. So let's now move on to the equation. So the equation of this graph, well, there's two ways to label it. You can do x of t, normal way, or you can use this capital X that indicates this function of time. I would prefer to use this x of t, but anyone can use it. So we're going to use x of t throughout this whole course. Okay. Alright, so now the equation for this graph is just 20, as there's nothing in it, it's constant, nothing. Okay? So that's the graph. Right. So let's move on to a different example of something that's actually moving. Right? So let's do another. So let's do another example. Let's say a smooth moving ball. I don't want to do rolling, as rolling is a complicated movement form. Okay? So let's say Tinito is moving at a constant speed, continuing on forever. We're not going to use friction. It's complicated. So let's do the graph. There. So Tinito. So we're at x0. We call this x0. So x0 is at 20. If it's not at the origin, if a point where it starts is not at the origin, we call it x0. Okay, so x0, or it could be at the origin, but we're just gonna, for most case scenario, we just call if its path is greater than the origin or less than the origin, we name it x0. So x0, again, is 20 centimeters. And let's say it goes up steadily, and yeah. So that's your, that's your graph of it. Okay. Now let's make some observations about this ball right here. So this ball has velocity. Velocity is essentially just the slope of the line, or of this, just the slope. So okay, now we can actually derive pretty much velocity from this. We can have, so x of t is equal to, it's going to be x0 plus the velocity times t. So this will v right here is what we call velocity is a cursive v. So there's many ways you can do it, but that's normally velocity you'll see in physics papers, math papers, everything. So if this looks familiar to you, good. It looks like slope-intercept form. Y equals mx with b. And you're not necessarily, if you're pretty much, okay. So x of t, this is the same as y, okay? So it's or f of x. This is pretty much the same thing. It's just describing a function, but in this case it's time, okay? So this mx right here is pretty much this velocity t, because you have your slope right there times something you will change if you plug in your function, and this x0 is pretty much b with y-intercept. So this is essentially y equals mx plus b. Okay, so we're going to conclude the video there. I'll have another video posted right after this, and we're going to go on to more about velocity. Have a great day.